Okay, now we are do drafting for assembly. Yes, maybe you want to create a bill of material of your assembly in drafting in 2D drawing. And now we get started. First to do, create a new for drafting. You have to select this one first, mechanical design and drafting. You can create a new drafting. And to get started, you have to blank paper and select blank in here. In this case, we use the A2 paper, standard ISO, and the style is landscape ISO and A2 ISO and landscape. For the paper size, it has A2 size. This size is about this ISO standard 420 multiply 594 millimeter. After see the drafting workbench, I mean, you have to select this one, properties, go to tag tree in here, go to properties, and there are two kind of projection in here, and first angle, European angle, or American standard. If I'm not wrong, I think using this third angle is better because first angle something confusing for projection. I select the third angle is the best for my case, because when you projection, this will show the right is right view is a right view. I mean, for left view is a correct left view. So this one is, you have to know the third angle is American standard. I mean, usually it has shape like this. The symbol is two circle. It has symbol like this. This one. Oh, I draw. This one means the view of this part. If you see from this side, it will show this two circle, right? If you see. So this kind of symbol. Okay, that is the paper size, and this one for front view, you select this planar surface on this side, and you can see in here your 2D view in the paper show like this, and there is some kind of function in here. Select the view in here and maybe just OK. And projection view for right view, something like this, and projection view for top view, something like this. Okay, let's make this projection: front view, right view, and top view. Okay, let's begin. Now is go to the drafting. I have this function in here, or you can go to mechanical design and select drafting. Okay, they suggest in here there is kind of blank, or this one all view, or like this type front bottom and right, or front, top, left, something like this. But we want to use our style. Okay, and this one is first angle symbol, this one. Okay, anyway, this one, select the A2 paper and type and style the paper is landscape, and okay, ISO. Okay, there is another standard, or Japanese standard GIS, or American standard, or NC standard. We use the international standard ISO, ISO, International Standard Organization, or whatever, ISO, and A2. Okay, click blank. Okay, scale is one by one. Okay. Okay, now we have this kind of view. You can minimize this size. I want to show you something. And this one is your assembly view, and this one is your drafting view. Okay, and in Tech 3 drawing you have to select this one, projection, this one first angle, this one third angle. If the first angle is the left view in the right position, something like this. Okay, that one is first angle, and the third angle, the left view and the left position, something like this. Okay, it depends on you. You want to use the first angle or third angle, but I recommend using third angle. And this one scale, okay, just okay. And let's begin the front view. You can see in here, this symbol is a front view. You select front view, and you have to select in assembly this face, this planar face. Okay, it's automatically show in here your 2D view, two-dimensional view. Let's place in this side for front view, or this one you can rotate for front view, this one, or like this, something like this, or you can rotate your view using this toolbar. I don't know how to say this one. Just change the orientation view. Okay, this one is the best, and click center, and this is your front view for your assembly. Okay, let's go to projection. This symbol, this icon, I mean projection view, and this one is right view, this one is top view. Okay, after you create this one, very easy, right? This one is, you can move this one. The red line means the active view, the main active view. You can move it together like this, or you can move this one. This one is lines in this horizontal, something like this. You cannot move to upward, something like this. You cannot move, so just move it. If you want to see the top view, I mean move top view, just move a line, something like this. You cannot drag on the left and right for this one. Okay, that's the drawing for assembly. Okay, I think this position is okay. And we want to create the cross-section view. After you create top view, right view, and front view, and you select this view, double click this view and become active view. As you can see, become red dot line in here in the frame. And you select the, after you select this cross section view, you have to select the axis for cutting plane. You can see there is cutting plane in here, something like this, or the center line, and then select the view, and you will have the cross section view, something like this. Very nice view. And you can modify this size of line, hatching line is depends on you, and you have to remember that the cross section, I mean the line is represent the material. If this a different style of line, it means a different component and different material. Okay, remember, different pitch and angle represent different component of material. Okay, in this case we just change pitch by double click this hatching space, maybe using different angle, in this case minus 30 degree, and pitch 3 millimeter. Okay, first you have to click this one, double click. Okay, become active frame. Okay, there is a cross section view in here. Select this one, and you have to create an axis in here. Okay, and you click, and you have cross section, something like this. Or you can modify this space, pitching from 2 millimeter in here. Okay, this one is minus 30 and 3 millimeter, something like this. And you should remember, if this has similar material and different component, you have to has different hatching. For example, in here is different components, right? And you have to, in this automatically has different size of hatching. In this case 150 degree, and this one 60 degree, and this one 150 degree, this one 30 degree. maybe you can adjust this hatching. So be careful with this hatching size. Maybe you set the same size. So maybe people will think this one. For example, you create this one 2 millimeter 30 degree, and this also create 30 degree with spacing 2. You can see in here this all same hatching, right? So maybe people will think this one is same component. So actually this one is different component. So be careful with this modification. So people will think this material is same with this material. So you have to carefully see. So you have to carefully change the style of this hatching. Previously is 5 degree, I think. So this one is all different. Okay, so people can distinguish this one as different component. Okay. Okay, whatever. That was the cross section view. So what is next? So we want to create another view in here with a nice view. So in here we use enhance skin in here. In the skin use, we have to not explode, actually just make a nice view in here using this function. And using compass method, you just move each part in here. After making nice view, something like this, make arrangement, you have to save viewpoint, I mean, and exit the skin. In the skin, you can create a new isometric view in here and select a skin 1 in here. So you have a nice isometric view with the explode component, something like this. Okay, and maybe you can adjust the view using this, but in this view I think is sufficient. I mean, in this case I just change the view something like this. Okay, explode view is an enhance view, something like this, using isometric view. Okay, understand? I wish you understand. Okay, let's go back to assembly first. Okay, in assembly, there is kind of this symbol using skin and automatic naming and float mode partial. Did I put this one in PPT? I think no. I think just use partial. Okay. Warning, just close this one. I think I can hide the Oh, not this. I will hide the wheel. I think I will hide the section. In here, you just move this component, something like this. Okay, I will move this one, sorry, one by one. Using function drag and drop. Okay, this is very nice view. Okay, I make something like this. Maybe go to front view, something like this, or isometric view, something like this. This one is very nice view. Okay, just like this. And the next things to do, you have to save viewpoint. Save it, and you can see this skin.1 is appear here. Save it and go to exit skin, and you have new skin here. Okay, after you create a new skin, go back to drawing and select this one, isometric view, and select this skin. Select this skin and maybe select the face, skin and face here. As you can see, you have a new view here. The you can rotate something like this. Something like this. I don't know how to better view. Maybe this view is better, but it's more we have to move this part down a little bit. Okay. Okay, this you have exploded view in here. You can double click this one. Can move all this view below a little bit. Okay, so you have new isometric view in here. Very nice view. Maybe this one move a little bit there. Okay, it depends on you. Just arrange this view. Okay, this one is very nice view, so people can understand what's the assembly exactly the each component looks like. Okay. Okay, after skin and isometric view, and the last one is create a bill of material. Okay, and for bill of material, we want to create a numbering. So select this number for letter A, B, C, A B C D whatever, what A B C D E F until Z. If you have a lot of parts, it depends on you. Or maybe you want to use the numbering 1, 2, 3. It depends on you. Okay. And the bill of material, you go to assembly first and analyze. There is the tab here, analyze, and select bill of material in here, and you can see it will appear the selection in here, and select a format, and you can check something like in here. This one is default quantity, part number, type, nomenclature, and revision. Okay, I think just a default bill of material I use in here. And after that, you have to create balloons. Because you select the number, not number, letter. Okay, create balloons and click active paper, active frame here. And you just double click to activate this balloon. And this one automatically show the balloon in your part in here, part 1, part 2, or part 3. What is part 8? That's it. For example, in here, this balloon A show the wheel part. Maybe C, this one support, or I don't know. Or maybe this support is E, and this one is B is for base, and D is sometimes this balloon, maybe you have to move it in correct position because it's automatically generated. Okay, after create balloon, something like this is very nice to see the components with the balloon. You see the components notation in here. Okay, after that you can insert bill of material on sketch. What is bill of material? Bill of material is the amount of your part inside your assembly. For example, in here you can see the number of the quantity of your part. For example, in here wheel is quantity is 1, base is 1, pin is 1, socket 2, and support is 2 quantity. This is bill of material. You can go to insert, generation, bill of material, and then nothing to do with this. I think just select the paper and it will show the bill of material in on the drafting. Okay, what should I do in here? First, go to analyze and bill of material. Go to assembly, and there is the type of part, quantity. Okay, define formats. There is no another format. Display the search order. I will set this one default. Okay, that one's bill of material. And you create the balloons in here. Where is it? This kind of icon, this one. Generate dimensions, and you have two options here, or three options here. Generate balloons. Oh, assign a number. Sorry. Cannot generate balloons because you haven't. First, you have to assign number. Okay, numbering. Go to assembly. Numbering. Where is the number? Product. Okay. First, numbering. It depends on you using one or letter A. I choose A, B, C, D. Okay. Okay. And generate balloon again. Okay, it's very nice. So you can see the notation in here. E for wheel. This one. A for base. B I think is okay. Support. I think C is for shaft. This one is for socket and this one is for wheel. Okay. I think you can increase the font in here. You can see the more clearly the letter. Okay. Okay, this is very nice. And you have to double click this one for active frame and you set the active and set the create balloon again. And you drag this atom as you wish. Move it this one and set the font. Okay, how about this? Same, very easy. Just sorry, the double click first and type a set balloon. As you can see, oh, number C is pin, D is socket, and B in here the support. Okay, and A in here, or you can move it this one over here, over here. Okay, so very nice looking. There is no E for wheel because wheel we don't insert in this view. Okay, change the letter size or letter font. Okay, sorry, double click this one and you have this balloon again. Change one by one. I don't know, I just use this method one by one. If you have found something interesting to change this more better, just tell me. Okay, I changed this one, something like this. Oh, this one is font D. Okay, this one, oh, this one 7. Okay, this is very nice. Okay, or you can move it this balloon in here, in here, or in here. Okay, this one. Last thing to do, you insert bill of material. To do this, insert generation bill of material, advance bill of material. Okay, I think just click this. And it will appear bill of material for this drawing, for this frame. Or you can select for this one. Anyway, I select this one, not this one. Okay, you can see here the number of how many parts you have in here. Let's call it bill of material. Okay. Okay, the last is you can deactivate this frame. Select this one. And also grid. So this one is final assembly drafting for this lecture. Okay, you can save it. It depends on you. In here, I save in desktop, maybe lecture and drawing, and name drawing 1, and the type is cat drawing. Okay, or you can save for AutoCAD file. I don't know, AutoCAD, maybe the drawing this one. I think DWG or DXF. I forgot. I think this one. This one is for AutoCAD. Please remind me if I'm not wrong. Maybe this one you can, or IGS. I don't know. You can convert to PDF also. This kind of drawing or GPG in here, or 3D. Oh no, catalog. Oh no, catalog. Maybe convert to PDF. You can see in here. Can save. And if you see on my desktop, oh sorry, maybe you can minimize this one. In this one, you can see the PDF file of your drafting assembly. Okay, this one, very nice looking, right? That is the drafting assembly. Okay, this one just display off frame and grid off. Okay, so we move to drafting part. After you create the drafting assembly, just like that. I hope you understand for drafting assembly and insert bill of material and create balloons. Make a notation for your assembly. Okay, we drafting part. In drafting part, you have to do self-study, maybe at your home. I make some kind of this drafting for, in this case, for base with line thickness 0.7 millimeter and font dimension 7 in this case, and hatch spacing, I mean 5 millimeter is default. This one is hatching. It has a space dimension around about 5 millimeter. Maybe you can practice for base and also support, also pin. This one is very easy. Socket and also wheel. Drafting actually very easy. What's difficult is to make model. So in drafting, I will show you for base only, and for support, pin, socket, wheel, I think you can practice on your home for self-study. Okay, I will show you for base. In this case, we want to create drafting something like this. Okay, the first thing to do, maybe this is a front view. We make a view for front view, something like this view, and create a dimension for your part. And you want to tell to everybody or everyone, and maybe in workshop and in the factory you want to make this kind of part, so you need to tell to everybody your dimension of your part. You have to create a drafting for your design, and this base has dimension this length 136, something like this, and it has radius something like this 14, length 82. This dimension is generated basically based on your design in 3D model. So this dimension is follow your 3D models basically. Okay, and you create this kind of template. This template is I made default from CATIA, and there is a logo in here, symbol of third angle view, and the name of part, and the scale, and the weight, and maybe designed by, I don't put the name in here. Okay, this just started. Okay, this one is assembly, I think finish. Kanasoyo finish. And we create a new drafting. Paper is A3 standard ISO. Okay, create a new drafting in here. So select the new front view. For front view, we have to select the base. I already opened base in here. Where's this? Yeah, this one. This base, I will show you in here, drawing to this one. Drawing to this one. Okay. Okay, we already select this front view, right? And you just select this view, I mean this plane. Sorry, where is gone? This gone. Okay, again, front view and select this face. Okay, basically this one is front view. Okay, and place in here. Okay, everything is okay. And after this, maybe first beginning, you can create a template. To create the template, you can go to edit, and see background. Okay, and there is kind of icon, frame, and title block. And select this one. Okay, and in CATIA they provide this kind of nice template, only 3 templates. Okay, I just use default template, this one. You can apply, and this one you can modify it in here. Okay, my name is this one, or change it, maybe this one. There is no name and there is no date. Okay, check by and that you can change it, this one. Maybe you can change unit in here. Maybe this one change by, maybe this one change amount or quantity. Maybe just change this one and this one. You can change by yourself. Maybe you need this one. This is very important. Maybe people cannot understand your dimension of this inch or unit, millimeter, or another length unit. You have to define this. So this one millimeter and amount is 1. So drawing number is base. And this is your company name, maybe. This one is company name. If you work in your company, maybe you have to create your company name. And to go back, you can go to working views in here. Edit sheet background. After you edit everything, you can working view, same. And in drafting, usually for part, it has the 0.7 lines thickness. So in my case, I change line thickness in here. This one is type thickness style. This one is thickness. Usually for part is 0.7. See, more thicker than before. And in here I set for more bigger view so people can see clearly my dimension. And similar like before, projection view. Oh, you should remember this one is not third angle. So I delete that. That's cool. You should select this one, third angle. Okay, and my mistake. This one is third angle. There is no update in here. So in this paper, This symbol, I think we have to put again. Maybe delete this one. Delete that one and create again. So this one is just leave it like this. You can change it this one as you want. I don't want to change it. I did mistake. First, you have to select this one, third angle first. Okay, and you can put the frame or template, something like that. Okay, let's begin from the beginning. And go to front. Select this. Okay. Okay, in for part, says thickness is 0.7. And I just make it this one font is 7. And now we begin projection view. So this one is top view, as you can see. To give the dimension, you just go to the this one. This one is dimension, change dimension, or you create a radius or diameter or chamfer or thread dimension, and basically we just create the dimension. Just click this line, you can see automatically uh, set the dimension in here. I don't know how to change this font in default as I want. In CATIA is basically for drafting is not perfect for me. So I changed this one uh, manually, one by one. I mean, you can change this one. Oh, this thickness is mistaken. Usually, axis is has thickness. Axis has thickness 0.35. For axis, it has thickness 0.35. For this solid line, this one is 0.7 for standard. And you want to create something like cross-section view. So double click this one. So this frame activate. So select this cross-section view. So in the middle, in here, you have a nice view of the cross-section. Or maybe you can change this hedge space, be more close each other. So set to millimeter. Okay. I will see this one. I draw something like this. And you just give a dimension for rest of the size. For example, in here you have a radius for here. This one is first style, radius something like this. And there is a second style. You have to select this one, and third style like this. this kind of radius, or this one, something like this. So whatever it is, follow the style of this. Okay, I just give the dimension radius for thin. Very easy, right? You can change the style and font size manually. Select it from here. Okay, I like this style. Maybe not people can see my drawing, not confused when see my design, something like this. Okay, you can draw the length of this one, something like this. Okay, for this one 82 millimeter, and you want to set dimension of this. Just move that top view, set not set thickness, and it has the 60 and this dimension. You just give all dimension. Maybe tell to people this dimension has 14 size, something like this, or you drag to out this one. Please remember when you create a dimension, uh, this uh, this dimension inside of part usually is not good. You have to drag outside the part, so leave the part inside without a dimension as possible. If not possible, you can put inside like this. I don't know, maybe this one is if you look at like this, maybe you create dimension like this or like this. Very confused, right? Very confusing, people. Maybe this one is not so good for dimensioning inside the part. You have to put out in your dimension out. So this one is very clear for people can see the part of your out of dimension in here. It's very clear and very nice to see, so people can understand your drawing. Okay, maybe you create like this. Okay, I just give this all everything, or maybe this one also 60, something like this. Tell to everybody this one is 60 millimeter and it has thickness 16. Don't put like in here. This is not so good. So you have to drag to out dimension so people can understand your part easily. See? Okay. If you put inside like this, it's a very bad dimension. very bad position, I mean, so people can recognize easily. So this one is better position. So these are thickness of 16, and you have to show the dimension of the hole also in here, and I will give all dimension in here. Okay, drag this out. Okay, there is automatically dimension, but I don't recommend use that because it's something like weird. Okay, this you have a hole. You can use the diameter dimension in here, something like this, and you can change the style, something like this. You have to change the font, something like this. Okay, it has diameter 11, and you can double click this. Oh, sorry, not double click. Properties, and you can go to dimension text, and here you want to tell 4 holes, so you can apply something like this, something like this. Or this one, I think no need space. This one is better. Representation. This is too big. Okay, this one is, I think, very clear. Maybe you can create new dimension in here, so people can understand easily your drawing. And you can change this. Okay, just make it a dimension, basically. I think it's very easy, right? It depends on your creativity and depends on which part you want to communicate, you want to tell, you want to inform, you want to tell to people in workshop which dimension you have it. In here, 12. I think this one is not meaningful, put in here. In the PPT, I draw this one 4 and 16, 12, something like that. I make a difference from the PPT. Or this one you can tell to like this or like this. Okay. Okay, I think this one is enough. Okay, so this one is final drawing of dimension or final drafting, I mean. So I think it's easy for you. You can do also, and you can create a dimensioning of your drawing on drafting. I don't activate this frame. Can move this in here or more a little bit down. Okay, this one is very looking nice. You can edit this one. Previously I did a mistake in here. You can rename it in here. You can rename it. This one is space. This one is your company. Sorry, maybe this one is drawing number. This one is name, like this. So people can understand. This one is name is base, drawing number one. This CATIA is something weird. Okay. And in drafting, I think I don't teach you about tolerance, and I wish you can study by yourself or in drafting in here. I'm looking for surface roughness in here. Maybe you should tell me where is it. This one cross section view. Intolerance. There is no tolerance. I mean, there is no surface roughness for this one. I don't know. In CATIA, it's not the best for drafting. Okay, anyway, you finish this drafting. If you have any question, you can contact me. And I think this one is finished, and you can convert this one and you can save it. You can save this drawing. Drawing 2, or name is a base. Cat drawing. Okay. You can save as for maybe PDF or AutoCAD, maybe DXF, or I don't know. Maybe GPG. Save this one to GPG. As we can see in here, you have a GPG drawing. It's very nice. Oh, this one is not thickness, is different. Okay, I don't change this thickness. You have to change 0.7. And you can save as again. To picture. Where is it? This one. So are looking very nice. Or can we export to another? There is no too much option in here. Anyway, this one is your final lecture for this class. So I wish you understand drafting. Okay, I think finish in our lecture. So I just show you how to make a drafting in here. Very nice drafting for your part. Okay, in this case, I just show you how to create for base. For another part, Another part you can create by yourself. This one, pin, socket, and wheel, you can practice at your home. So if you have any question for Katia, maybe you can contact me. And thank you very much for your attention and have a good day. And thank you very much.